Hi everyone. Today we're going to look at a slightly different scenario. So in these questions, if you take a second and read it, you'll notice that there's two things going on here. So I'm going to sketch them out here first. I'm going to pause it for a second while I sketch it. I like to include a sketch so I can kind of figure out what's going on. So I've got Billy and I've got Jimmy, and they are 300 meters apart at this moment in time. And so the question is, how long does it take Billy to catch Jimmy? Except I'm missing information. I need some to figure out what's going on. So I read the question. It says Billy's running. I'm going to assume it's constant velocity. It doesn't tell me otherwise. So Billy's running at 4 meters per second. And up ahead is Jimmy running at 2.5 meters per second. And they're 300 meters apart. So if that's the case, I'm going to say that Billy's initial position is 0 meters. And Jimmy's initial position is 300 meters. So he's actually up ahead if I'm looking at this on a number line. I could have said Jimmy's 0 and Billy's at negative 300. It doesn't matter. And it doesn't say east. I probably should have put that in there, but we're going to assume they're running right otherwise. And it says, when do they catch up? So I don't know how long Billy runs for, and I don't know how long Jimmy runs for. And I don't know where they meet up at either. So right now, I've come upon this, and I have two unknowns. I'm missing the time and the position, but I know the following things. So that's not an in. I know x from Billy equals x from Jimmy, and I know that t for Billy is the same amount of time that it is for Jimmy. So since I know these, I have two unknowns, and I have two unknowns, but um, I have two people going on. So these are the same. If I have two unknowns and two people, then I know that if I'm trying to solve this, then I need two equations. So what I'm going to do here is I'm going to say, well, the formula for Billy would be this formula. And in fact, it's the same formula for Jimmy. Now, it might not be. If he has an acceleration, we'd have a different formula, but I'm starting off with the basics. So I know that the equation is the same for both of them. I also know that the x position is the same for both of them. So I'm going to say that x for Billy equals x for Jimmy. With that being said, this part of the equation equals this part of the equation. So x naught for Billy plus his velocity times his time is equal to x naught for Jimmy plus his velocity times time. In this case, this time is the same, and I have the other variables, so I can solve for the time, and I will know when Billy catches up to Jimmy. So if this is the case, we know that's 0, because we said we're going to make Billy 0. 4 and a t, and on this side, he started at 300, plus 2.5 t. Now I just do some simple rearranging. I'm going to move this to the other side and subtract it. I'm going to have 1.5 t equals 300 meters. Therefore, t divided by the 1.5 is going to equal 200 seconds. So Billy should be able to catch up to Jimmy in 200 seconds. So I can check this. So I can answer the second part of the question. The second part was, how far does he travel? So I can go back and find where Billy gets to. I'll write my equation back down. And I only need to do it once, but I'm going to do it twice. That's 0. This is 4 times 200. So between zeros. So Billy would have to run 800 meters. If I did this right, and I check Jimmy's distance, they should end up at the same spot. So x for Jimmy is he started at 300 plus 2.5 times 200. 2.5 times 200 is 500. So the end result for Jimmy is also 800. So they've ran this to the same final point. Jimmy only actually ran 500 meters because he already had a 300 meter start, but they both had the same final position. So then this worked out. If these two answers didn't work out to the same number, not accounting for little rounding issues, but if they weren't close to each other, then this wouldn't work. So To summarize, if you have two objects traveling at different rates that meet up, either they're moving towards each other or away from each other, you need to make an equation for each object. Usually both objects will share the same final position in time. For anything we're doing, that's what's going to happen. Set the equations equal to each other, which eliminates one of the variables. You could also do substitution, but I like to set them equal to each other, elimination. And then, if necessary, use the quadratic equation or a solver if it's needed. This will be a case where you have someone with an acceleration and they don't start at the same spot, and you'll see those in the extra questions we're going to do. But hopefully this example kind of works through what's going on. If we have two unknowns, anytime we have two unknowns, we have to have two equations. And if I have the two equations, like set them equal to each other, eliminate the one variable, and then solve for the other one, and then I can substitute it back in. So I hope that made sense. If not, we'll be going over some in class, but I just wanted to kind of give you an introduction to this. And we'll go over it when we see each other again. Thanks.